Question 5.3 and 5.4, I've got the Arrhenius equation here, and what it wants me to do first of all is take temperature and divide 1 divided by temperature. So 302 divided 1 divided by 302 works out at 3.31 times 10 to the minus 3. For this one here, it's got 1 divided by t, and so here I need to do ln 1 over t, and so a natural log of 1 over t is natural log of 3.7 times 10 to the minus 2, and it comes out as minus 3.30. Okay, so now I've got 1 over temperature here. I've worked out 1 over temperature, and I've got 1 over time here, and I've got natural log of 1 over time. You don't need to worry too much about why we're doing this. We're doing this to fit in with this equation here, but it leads you through. It'll always lead you through. It now asks you to draw a graph, and it asks you to draw a graph to plot a graph of 1 over t is the y-axis, ln 1 over t, which is this one. So you've got to plot these points on the y-axis against 1 over t, which is the temperature on the grid. And so it will look a little bit like this. You'll get a straight line graph where here you've got natural log of 1 over time, and you've got 1 over temperature along the x-axis. And as long as you use at least half the graph paper, plot the points correctly and put a line of best fit, you'll get 3 marks for the graph and 2 marks just filling out the table. So where are the other marks from then now? So you need to work out activation energy. The next thing you've got to do is work out the gradient. If you work out the gradient, that's how far down it's gone divided by how far across it's gone. So you draw a triangle. If you draw a triangle and measure the height and divide by the width, then you should end up with a number that's in the region of 6640. It's a minus number because the line's coming down, and that equals minus activation energy divided by R, which is 8.31. That's just something to remember. When you plot these graphs, when it asks you to plot these graphs, the gradient equals minus activation energy divided by 8.31. If you want an explanation of that, then I give an explanation of that in the previous video on 2017 paper. I can reverse both sides, so now 6640, there shouldn't be a minus there. Activation energy is 6640 multiplied by 8.31, so I've taken the 2 minus signs away from each side, so 6640 multiplied by R, which is 8.31, equals the activation energy 55178, and it's in joules per mole. And then I need to turn it into kilojoules per mole by dividing by 1000 and rounding it up to 3 significant figures, because all of the other numbers are in 3 significant figures. How do I know that's in joules rather than kilojoules? Because it tells me here that R is in joules per Kelvin per mole, so that's in joules, so this must work out in joules. I need to convert it to kilojoules.